Okay, it's time to build a Geogebra model for our linear functions. And I'll just show you real quickly graphing a line. So y equals 2x plus 2. Graphs a line right there, and you see that my initial condition was 2. My slope was 2, right? So I'm going, for every 1, I'm going up 2 and over 1. But that's just graphing a single line, but I want to graph a whole bunch of lines and be able to switch between them all. So I'm just going to click on that and delete it. And also I want to look at a table of values, so I'm going to open up a spreadsheet. So I go to View, Spreadsheet, and this will give me a table of values. And I need to tell you about a little bit of a notation. To put it into GeoGebra, the way that they like the lines to be written is like function f parentheses of x equals, and then I would do like 2x plus 2. So this is a function that is in terms of x, and that's what f parentheses x means. So that's how you write functions in GeoGebra. And you can see it does the same thing. It says f of x, that's how you say it, is a function of f of x equals 2x plus 2. Now before I do that, I want to do some slider bars so I can change the slope and the initial condition as much as I like. So let's do that, slider bar. So we can call it M. I'm going to call it A this time. A, and I want to be able to switch it between -5 and 5 on an increment of 0.1. Okay, that's fine. Okay, and then I'll do another one, B, and it can go from -5 to 5 on an increment of 0.1. Okay, so now I can adjust those that way. Now I'm going to write my function f of x equals a times x. So you could have done mx plus b if you want to make that a and m. It doesn't make any difference. So I'm going to do ax plus b. And so the times is just the asterisk. So take a look at that. And there it is. So now when I change the value of a, so I make it 2. Now for every 1 it's going up 2. Okay, and then if I change the b, see what happens. So if I go to 0, then my y-intercept is 0. And if I go to -2, where is it? Right there, then my y-intercept is -2. Alright, so I want to get a list of values out of this spreadsheet, so I'm going to, let's have my starting value be, actually let's make a slider bar out of it while we're here. Let's say starting value, or starting, and I want to start probably no less than 0, so I'm going to go 0, maybe -10, increment of 1. Yeah, I don't care about the decimal points for starting value. Okay, so starting, it could start at 0, and then my values will go up by a step. So I'm going to make another slider for step, and the step could be minimum would be 0.1, maximum maybe step of 10, increment of 0.1. Okay. And we'll start with a step of 1. Okay, so I'm going to have cell A1 will be my starting value, so I just type starting. And it's starting at 0, just like I expected. So if I change this, see it starts at a different value. And then for each step, it's going to go up by 1 right now. So it's going to be equal to whatever this value was, A1, plus the step. Okay, so it goes up by 1. So this is starting plus step, 0 plus 1, and then I'm going to copy that formula down so every time it goes up by 1. Yeah, worked out. Okay, so and then my y value will be whatever the function value is at that x value. So this is like my x value, this is my function value. So it's equal to f of, and then I put, instead of x here, I'm going to put the value. So f of 0, or f of a1, whatever is in that cell, it's going to give me the function evaluated at that value. And you can see that f of 0 is -2. And if I just copy that formula, so I go and I hover over the corner and drag it down, and now it's evaluating the function. See, function at a6, so function evaluated at 5 is 8, and once I put in my list of points, it will show me that point. So I highlight all of these, I click and drag, and then I go to create list of, I right click on those and I create list of points, and then it will put the points on there. Now I don't like these letters A, B, C, D. I want it to actually tell me the value. So I go to point and right click, and I do object properties, and I don't like the name, I want it to just tell me the value. And once you do that, you hit X and O. So there it goes. So 0, -2, 1, 0, 2, 2, 3, 4. See, so all the points here are listed here. And if I change my starting value, so that all it does is now I start at -2, and you can see like the starting point at -2, and it's going up by 1 each time for the step. And now I have all these points. So if I zoom out, I can see all the points that I've made right in there. And if I start lower and lower and lower, it'll just shift this whole column over. Now if I wanted to increase my step, so what happens if I just check every point, so every 3 or every 4, so -6 and -2, it will just check those points. But I think, or maybe I'll make my step smaller, I can see what it looks like every point 1, right? And let's start at 0. So if I start at 0, my first point is 0, -2, and then point 1 times 2 minus 2 is -1.8, which is right there. So you can see that the slope is always the same for all these points. So let me go back to 1. Alright, and scroll wheel out. Alright, now that was playing around with just plugging in points and seeing what the function value equals. What happens when I change my slope? So if my slope goes down, the steepness goes down, right? And when it gets to 0, what do you think happens? It is flat, right? So 0 means you have f of x equals 0 times x minus 2. So whatever x is, it's always going to be equal to -2. And you can see that in the graph that the f of x value is always -2. And you see here in the table, it's always -2. Okay, now what happens when I go negative on A? See, now the slope is going down and to the right. Down and to the right, up and to the right, down and to the right, up to the right. It's always, you always think of it as the slope going to the right. But if it's positive, it's going up, and when it's negative, it's going down. And when it's 0, it's a horizontal line. Now, can you ever make a vertical line? So I get to 5, I'm still not vertical, right? What if I went to 1,000? Well, 1,000, I would still go up 1,000 over 1, right? So it would still not be vertical. So it's actually not a function at that point. It's not a linear function if you have a vertical line. You can put in a vertical line into Geogebra. You just have to say what the x value is. So you say, want to make a vertical line through x equals 6. You say x equals 6, and see it makes a vertical line. So that's not a function, though. It's just what is the x value. So I want to get rid of that, so I have to select it. Delete. Okay. What else? So what about the b value? What does it do when I change? So it just changes the y-intercept. So when I'm at 0, my function is now just 5x. There's nothing added on to it, right? So when I change my slope there, you can see it's always going to be a line that goes through the origin when your b value is 0. And you can see that the 0 value always stays the same no matter what the slope is. So even if I moved the b value up, if I change the slope, the 0 value stays the same. It's always going to be 2.1. See, you can see that in the table values. So there's a lot going on here that all works together with the graphic view. What is your linear term? What is your constant term? And how does it work with the table of values? Your 0 value is always your y-intercept. It's always your b value. Your rate of change is always your a value, or in your linear term, or it's the difference between, so actually let me just do that, equals, what's the difference between this value and this value, right? So I did b2 minus b1. I bet you it is right now 2.4. Yep, I was right. And I bet you all of these values, the difference between the adjacent values will always be 2.4. And there it is. So you can see that the difference between b11 and b10 is 2.4. And so as I change the slope, you can see the difference between adjacent values is always going to be that value. So it's going up by 3.8 right now, up by 3.8, up by 3.8. Now it will mess up if I change my step. I'm on a unit step of 1, but if I change the unit step, you see it goes off. But as long as my change is just 1 unit, then it will be the difference between those adjacent values will be the same. Okay, so you're going to make your own model and experiment with it and send that over to your teacher and have fun with it.